Okay, welcome back, everybody. Our next presenter is Harley Davis, who is CEO and co-founder of Athena Decision Systems. This is a Paris-based consultancy specializing in accountable AI solutions that combines generative AI, business rules, and all other decision management technologies. And it so happens that I know Harley personally since the time he served as a director of iLog Consulting worldwide. And before starting Athena, Harley was leading R&D for IBM France. I'm correct? And today Harley will share his experience with this recently started a new company, but already who has real world customers, and they have real world applications of decision intelligence technology. And that's why one of the reasons I expect Harley presentations would be very, very interesting for many of our attendees. Harley, take over.
All right. Thank you so much, Jacob. That was a very, very nice introduction. So yeah, I'm Harley Davis, founder and CEO of Athena Decision Systems. And as Jacob said in this talk, I want to give some practical patterns for how to combine generative AI and symbolic decisions in what we call accountable AI systems. And I want to use real examples from the public service. Let me start with a personal story. So I am an American living in France. I've been living here for quite a while. I'm not a citizen, so I have a 10-year residency visa that I have to re-up every 10 years. And in 2023, I had left IBM and I was wanting to start Athena. But my residency visa, what's called a carte de séjour, it was about to expire. And I had to renew it through, in France, the administrative agency is called the prefecture. And in order to renew my visa, I had to get a face-to-face appointment at the prefecture, but I couldn't get one at all. The online system they put in place had no available appointments. Their website was a confusing mess of interlinked different FAQs with very complicated different cases to try to find yourself in. They wouldn't take phone calls. Finally, I found an email address to try to send them an email. I sent them several emails, no dice. I was starting to panic because I couldn't start the company without my visa renewed. And then finally, I was able to get an appointment through personal connections. So I solved my problem, but I solved it completely outside the standard system. And that really made me wonder, if I have this problem, then how many other people are experiencing the same kind of problem without having anyone they can call? And indeed, we discovered later, we'll talk about it, that the prefecture was receiving far more emails and far more messages than its staff could possibly process. And they had really no way to understand and organize all of those messages, figure out what the urgent cases really were, route them to the right person, and figure out what the right response was. So we went to the prefecture. Well, after I managed to get the company started, we went back to the prefecture with a proposal to kind of, well, I'll talk about what it is later. They recognized the value of what we were trying to propose and got very enthusiastic about it. And that became our first reference customer for this kind of accountable AI technology. And so I want to tell you about what we learned in this and other cases and how we're building upon it. So real fast, Jacob was kind enough to mention my background a little bit, so I won't go over it again. I hate talking about myself anyway, but yeah, I led the IBM R&D lab. I led the IBM decision management products for quite a few years. I led the development of IBM's first agentic AI platform called Watson Orchestrate. And then I left a few years ago to start Athena. And Athena, we're really a European-based decision management consultancy. Our focus is on accountable AI. I tried to bring together the best decision management people that I could that were available in Europe at the time. So we have a great team of really senior people. We have some IP that I'll talk about, and we've gotten a fairly good set of customers in the first few years, and we're partnering with quite a few other people as well. And we're happy to partner with more. We'll be happy to have that discussion if you want. All right, let's talk about the subject of this talk. First of all, I want to talk about when I say accountable AI, it's not really a term that everybody is using, but I want to explain really what we mean by that. Some people say hybrid AI. Some people say neurosymbolic AI. We say accountable AI, but the idea is the same. We use AI to interpret natural language, to understand intentions and convert natural language into structured data. We ground that interpretation in facts, whether those are represented as ontologies, case models, regulations, whatever. Decisions, however, real decisions are governed by business rules or other decision management technology. And therefore, the system is accountable. We're able to combine the best of what each tool brings to the table. I prefer to call this accountable AI rather than hybrid or neurosymbolic because accountability is really what it's all about. Accountability in the sense that the system is able to explain and justify its decisions because they're based on grounded, explicit rules that are tied back to policy, and accountability because people ultimately are in charge of validating all the different components of the system. Okay, so applying this idea to the public sector. What's the big problem in the public sector? Well, one of the big issues is that people, when they have a problem, they talk about their own personal situation in their own language, in human natural language. So for example, my problem is my residency permit is expiring next month. I'm trying to start a company. How do I proceed? Someone else, basic things can happen all the time. There's a broken street light outside my building. What should I do about it? I'm trying to address the problem to City Hall to get them to respond. And there's a million other situations like this that you express in your own language. Institutions, on the other hand, and public sectors are a prime example. They don't really think in terms of situations. They think in terms of categories. They think in terms of their internal organization. They think in terms of policy directives that were written over a historical period. And that leads them to construct systems and approaches to serve users that are based on their own hierarchy of how cases are broken down. So for example, it's in French, I apologize, but it's a small subset of the different subcases of all the different visa categories in France. So if you want to actually renew your visa and you want to use the systems that they put online, you have to try to figure out which of these and many more that they have that apply to you, try to find the rules that apply, try to figure out what forms or other online systems apply, and it's basically a mess. So the real problem that we're trying to face is how do we bridge this gap between how people think about and how people express their own situations and how institutions need to manage those situations and how they currently present a rather ungoverned, rather difficult interface to users. Now, at the same time, natural language is not executable policy, meaning that you can't simply express everything as a description of situations. There have to be rules, there have to be categories, there have to be these hierarchies in order to have reasonable policy management over time. Let me go back to the prefecture for a second, and then we'll talk about how we address what I call this taxonomy gap, or this gap between situations and taxonomy. In France, there's over 90 different prefectures, and one of the big jobs of a prefecture is to process residency permits for foreign residents. In Les Yvelines, which is the department of France where I live, there's 1.5 million residents, almost 200K foreigners, about 18,000 permit applications per year. And as I said before, it's very difficult to get an appointment. The emails pile up, and the website is almost impossible to use. But for people, for foreigners, even if they're in France completely legitimately, they're doing everything absolutely right, their status can be at risk very easily if the residency permit is not handled right. They can lose their employment, they can lose their housing benefits, they can lose their educational benefits, and generally their legal status. So it's a big problem. And for the state, it's also a big problem because if people are following the rules and the state is not able to meet the demand, this results in legal appeals, extremely bad press, very generally eroding trust in the administration. And for citizen services, of course, that's even worse because that creates electoral problems and a lot of pressure. This particular situation with foreigners in France has actually generated a lot of press in France. Here on the left, there's a headline from one of the major French newspapers that talked all about this problem. So the prefecture has a big problem, and their biggest problem right now is understanding which person's situations are urgent, who has to handle them, how should they respond, and how do they manage it. So this is the problem that we had tried to address. And we tried to address it with this application that we call DELF, which has a very elaborate AI-generated acronym meaning in French that I won't try to explain to you. But it's funny because we're called Athena, and it's DELF is like, the Delphic Oracle. Anyway, what happens with DELF? First thing is you as a user, well, not really citizens, but user describes your situation in your own words. The generative AI reads your situation and it tries to map it to a series of intentions, which essentially correspond to all that different hierarchy, those categories that I explained. It corresponds to some kind of ontology, internal ontology. And each element in that ontology, if you want to call it that, is basically a case. And once you've identified the case, you also know what data elements you need to extract to get from the person in order to handle that case. So we use generative AI as well to try to extract as many data elements as we can. And of course, we get people to validate what we've understood from their situation, which makes them feel understood and happy. We use business rules to understand, to assign priorities, to route the rules, to generate a preliminary response, and to generally help orient the request to the back office. But it's really important in this case that a case officer is the one who makes the final determination. But what they see is a structured case from the user and not just a homogeneous or set of emails that they have to go through, interpret, and try to prioritize themselves. So we're not trying to solve the problem of deciding whether you deserve a residence visa. We're trying to solve the problem of making sure that the most urgent cases and the most relevant cases get routed urgently to the right people and are able to be handled as efficiently as possible. So this system is operational. It's been operational for about 6 months now. We built it with IBM Decision Intelligence for the business rules part, and we'll be making a press release with IBM and with the prefecture in about a week and a half. And we're currently working on a security certification at the national level so we can deploy it more widely within France. We use Mistral, we use Scaleway, which is a French cloud provider. So everything is hosted and provided by French technology, which, as you might imagine, is important for the public sector in France. And as I said, it's built with IBM DI and with our own framework, which we call Athena Trusted Services, that I'll get into in a little bit. I want to show you Delph. I don't want to do a live demo because this is going to be a little bit easier to show you some of the key features. This is what the website looks like when you go to the prefecture website. And when you click on the fact that you're a foreigner, you now get this website, which says you have to use Delph. It's in English and French, obviously. I'm showing you the English version. Then you get a web form and you type in your problem. So here we have a problem with somebody who is trying to renew their residence permit. They have a talent passport, which is temporary. Um, they did that on March 3rd. They have an extension for their file, which expired yesterday. It's an important point. It says the API, which is not our API, but an API meaning the extension, expired yesterday. They're very worried, and their work contract has been suspended, so their job is at risk. So obviously, an urgent case with a very worried person with an expired permit. They type it into the system. We use generative AI to try to understand first what case this is. Okay, and if you look down here on the left, it says it's proposed the case expiration of an API, which is one of the dozens of possible intentions. So yes, that's what it is. If we click on that, then it asks us for some additional data. Are you an asylum seeker? No, there's nothing indicated, so this has been clicked no. And then what is the API expiration date? So this is interesting. So the system automatically filled in August 24th. I ran this a bit earlier today, so August 24th is what it came up with. Why August 24th? Well, there's two dates mentioned in the person's message. One is the 3rd of March, but that's not the expiration date. That's the talent passport. The API expiration date was expired yesterday. So the AI was smart enough to understand that that is the expiration date we're talking about and was able to automatically calculate that date and propose it to the user as data. So here we're clearly moving from person's description of the situation to a much more structured construct, which is more applicable and intelligible to the prefecture through the use of an LLM. So that's pretty cool. So then the user gets a nice little feedback. Your request has been processed. In other cases, we give them some kind of short, immediate answer if we can definitively determine. But for the most part, we just reassure them that they've been understood, that their case will be handled. And then we send an email off to the case officer in the back end. Okay, this is the view of the case officer. Now, this is super interesting. So the case officer was before, as I said, they were getting a homogeneous pile of hundreds of emails on a weekly basis. It's something like 300 or 400 emails per week that they were handling, of which they could only handle a small percentage in reality. There was no structure to the emails. There was no real information. And here, what they're getting now is a structured email with some data determined. And they're getting the original message from the user, but the key elements of this message have now been highlighted again completely by the LLM. So one key element, is there a risk of employment? Because that helps determine prioritization. Yes. Well, why? If you look at the color coding, it's because she said, my work contract is suspended, and if this continues, it will be terminated. So the LLM was able to determine that simply by reading the situation. What's the expiration date? We talked about that. It was expired since yesterday. That was also computed by the LLM. What's the tone? They're stressed. You can read it in green. Why? And does the case have to do with the NF, which is another website? Yes, this has some relevance to the response, but it's not relevant for you. In addition, there's an explanation for why this intent on the very bottom, why this intent was determined by the LLM. It tries to provide its own justification for its behavior, which you might think wouldn't work very well with an LLM, but it turns out it actually works really well for this case, at least. So that's pretty cool. So now the case officer gets a structured element. there's a proposed response as well that I'm not showing you here. And the case officer has a much easier time reacting to the email. Plus, because they're prioritized, the top priority emails now float to the top and they get handled first, which is what we were really after. So that's really cool. I'm happy. I'm happy to talk about it in more detail if you want, but that's the nature of the application that we developed. So it turns out this is a pretty common pattern in this kind of public service application. And I think it's a pattern not just in public sector, but more broadly. So we developed, based on this rather good experience, we developed a framework called Trusted Services. And the point of the framework is to take whatever is truly generalizable in this use case and put it in a framework so that future applications that we develop can be created much more easily. So what's common in all this? Clearly, the idea of going from mapping from a person's description of the situation to an intent to a case type, and doing all of the appropriate data extraction that we can based on their description, based on the formal structure of the case.
Harley, can I ask you, Harley,
of course,
you said that
please.
In this previous email categorization case, it was pure LLM work, or you used business rules? And if you did, can you give us a few examples of rules?
Yes. So as I said, the LLM is primarily used to map the user's description of their situation. So the text, the message the person writes, maps it onto the intent or the case type, and then you use the LLM to extract data to construct a formal description. Then that gets passed to the business rules, which determine, based on the public entity's own rules, what is the appropriate priority? What, if any, immediate response can we give them? Who should the message be routed to? And basically a recommendation to the case officer on what the treatment of the message should be. And that's done with business rules. So this is really, really combining both into one application.
Okay, good. Thank you.
So, like I said, the framework provides this the rule capability. It can use multiple BRMS systems. We aren't tied to IBM, except historically, I would say. And it provides a way to describe all the different intentions, what their different data fields are, and some of the prompts that would be used in order to help the LLM interpret common situations. We provide the ability to deploy it in a variety of different places. Again, public sector typically requires some notion of sovereign deployment. You can't just you can't call an LLM with personal data where the server is sitting in the US if you're a French prefecture. That's like no-fly zone. So in this case, we're actually using Mistral, hosted by a French cloud provider, and that's kind of part of the framework. So when we actually go to deploy it, and then adapters for different back office possibilities. In the case of the prefecture, they're using email. We have other cases where there's CRM or case management systems on the back end that we have to tie to directly. And then, of course, when you come to a specific case, you configure the framework with the set of intentions, the set of categories, the set of data, the specific business rules, the AI model and how it's hosted, et cetera, et cetera, et cetera, and the integration with the back office. And then the workflow for one of these cases, it's very much as I described. It starts with a user request written in natural language. In this case, it's via a web form. We have other cases where customers want things done multi-channel, so over the phone is one common request, and other possibilities as well. We determine the intention based on what the users say. User confirms it, including the data that we extract, or they correct it. We apply the rules, the business rules, produce a recommendation, send it back to the case officer, and the case officer is responsible for agreeing or not agreeing with our recommendation or making a final determination. So the public service retains complete accountability for the case, but with a much more structured set of data and a lot of derived information that they wouldn't ordinarily get. Okay, so let me give you another example. This is another case that we're currently working on. It's a city of Sèvres, which is a sizable suburb of Paris, about 52,000 people. And they have, um, as any city hall, they get a myriad of different requests from residents all the time, whether it's uh, a tree fell in my yard, to my neighbors are having a noisy party, can you get the police over here, to how do I get my kid into a public nursery school? The variety of requests sent to City Hall is simply endless, and the number of channels is also kind of endless. So, but essentially it's the same problem. They have a large set of different possible cases that they've actually defined. They have a number of channels where people can send their requests, and they have people on the back end who handle these cases once they've been identified. And they have a current problem where people get kind of lost because their website, as I kind of hinted at the beginning, their website is basically this huge hierarchical menu system that tries to get you to find exactly what case your problem belongs in before you can start filling out data and sending a request. So it's essentially unusable by the average mortal. And what people really want to do is simply say, hey, there's a cat in the tree, can you send the fireman? Um, Instead of selecting cat in the tree from the 12th level of the menu. So this is what we did. We used our trusted services framework. We developed a prototype for them showing a fairly large subset of their intentions. We linked it up to their back office system, and it works in a way very similar to the Delft system that I showed you before. They got extremely excited about this. The case officers were now getting these, you can't really read it here very easily, but they were now getting these color-coded, highlighted, structured descriptions of people's cases. People no longer had to sift through all the menus. They could simply say what was going on, and they got routed to the right place. And the high priority items, once again, floated directly to the top by applying a set of business rules, and they were directed to the right people inside the city. So they, like I said, they got super excited. There was a municipal election in France a few months ago, so we got a little bit delayed. But the new mayor, the new city, well, the same mayor got reelected, but the city council, the mayor, the entire city administration got super excited. So now we are developing the production application, and it should be in deployment if everything goes well, by the end of the year. So extremely cool secondary case. And I think this one, like the prefecture, which we are now certifying for use by the entire country, this one is probably applicable to most cities in France and probably outside of France as well, with some different variations. Okay, I'm just going to give you one more. It's a very, very short case. This is the city of Helsinki. They had a different type of problem, but we solved it in a similar way. They have the problem they were interested in was builders and other people who manage property in the city had all sorts of problems figuring out how to get building permits, figuring out how to find the right forms for their their plots of land for title transfer, for a bunch of other things related primarily to the building sector. So we didn't. They had a kind of public tender, or I guess you'd call it an extended hackathon, for doing experiments with AI in the city. We did a POC for them, or that we entered this experiment with a system that actually won the prize for the best municipal AI experiment, and it was essentially the same thing. In this case, it was a chatbot, which is what they preferred, but it was the same idea. As a builder, you type in your problem, what you're trying to achieve. We use the AI to determine exactly which intention, and then we leverage the mass of FAQs and website information that they already had available to try to A, determine an answer, and B, redirect the user to the right place where they could fill out the right form and get their problem handled correctly. So pretty cool. And we have more on the docket, which I'm not ready to talk about yet, but we're talking to other people with about similar cases, because clearly this problem is quite general, and I think the solution is quite reapplicable. So based on these examples, what have we learned about public sector AI? I would say if there's one word that we learned, because we had to go through a rather elaborate process with pretty much all of these customers and the other ones that we're working with, the most difficult thing is trust. AI, I think we as practitioners and as AI geeks, personally, I've been doing AI since I was at MIT in the mid 80s. So I'm like, a total addict. But the general public's perception is not the same, as we all know. And so when you start proposing using AI, it creates a big immediate trust gap that has to be overcome. And so this notion of focusing on accountability and focusing on AI proposing, but humans making the final determination, at least at first, is critical for getting that level of trust. And when they understand that what the AI is doing is not making a real decision, but what the AI is doing is simply understanding what people are talking about to make it easier for humans to make a decision with potentially a recommendation, you can overcome that first barrier of trust much more easily. And second, and related to this trust issue, is the idea that policies need to stay explicit. If you just throw everything at an LLM and say, tell me what to do, even if that includes policies that are correct, it doesn't really create a high level of trust. Even if you have good LLMs with good reasoning engines and you use the latest GPT 5.6 Sol with high reasoning level, and it gets the answer right every single time, which it does at a remarkable pace these days, still it doesn't engender trust. And the way to engender trust is to show the business rules, is to show that, for example, Jacob, you asked for a specific business rule. In the example I showed, we determined that the employment risk was high. Well, there's a specific business rule that says if employment risk is high, up the priority, if the work permit risk is high, if the person is likely to lose their job, up the priority level by 1 notch. That's an example of a business rule for this kind of application. So the policies have to stay explicit and under the control of the public service. Third, I had already mentioned, so I won't belabor the point, but supporting sovereign and local deployment of AI is critical, especially in Europe, where the mistrust of the US tech giants is extremely high. And you're not going to establish trust, at least outside the US, by sending people's personal private information about their employment situation and their visa situation to a big data center sitting somewhere in North Dakota. That's really important, at least in this country or in this continent. And the second is kind of growing over time, being progressive. The trust has to come a bit at a time. You don't try to solve the entire problem. You apply AI to a piece of the puzzle. You show them how it works. You show them how it's controlled, how we set up the guardrails with business rules, how we set up other guardrails around the listed intentions using structured output and structured input appropriately. And you grow the trust over time and grow out the application over time. And finally, integration with the legacy landscape has proven to be critical. We're never starting in a vacuum with these systems. We didn't want to go into the prefecture and say, we're going to, not only are we going to apply AI to solve this problem, but we're going to replace your stupid email system with a real case management system or a real BPM system because those are much better. We're going to do all that at once. No, that doesn't work. You use email, great. We're going to keep using email. We're just going to solve the biggest problem you have, which is making your email system effective. Then later, maybe we can have the discussion about applying business automation to a larger part of your organization. Okay, so that's the first thing I want to talk about. But making the decisions and understanding how residents or how the users of these systems operate with them is really only half the problem. And the other half of the problem is, I think, what Pierre has alluded to, what Alan kind of talked about, and I think what some of the other presenters are going to talk about, which is managing decision systems based on AI. And in the public sector, there are a large number of decision systems which make pretty important determinations. And I want to talk about one specific use case that we have in this area. But what's the issue? For things like pension calculations, for things like benefit calculations, for healthcare reimbursements, which is what I'm going to talk about, there is a definitive process that we need to follow and manage if we're going to use AI effectively. In most cases, the decisions that are being made by the public sector services come from legislation and directives, which are then mapped onto policy documents, which get a little bit more specific. In the cases we're interested in, these are mapped onto executable decision models, and then those, of course, are used to make decisions on specific cases. Now, I think we're going to show how I think AI can be leveraged at each one of those different steps, but it's important to understand the steps. First, when you're going from the legislation down to the decision models and the actual decisions, and how do you leverage AI at the different steps and kind of creating your executable decision process, but also on the back end, when decisions are actually made, they need to be justified and they need to be controlled. So after you make a decision, how do you back up and justify the decision that's being made by these automated systems all the way back up to the policy and the legislation that justifies them? This is really important in Europe, at least. We have GDPR and the AI Act, which require AI-based decisioning systems to be able to explain themselves. So kind of mastering these two layers is absolutely critical for success. Okay, let me get more specific. We work with the CNS Luxembourg. CNS is the Caisse Nationale de Santé, which means it's the Luxembourg health insurance fund that manages all the healthcare reimbursements for people covered by Luxembourg health insurance. In Luxembourg, it may seem like a small country, but there's over 1 million people who are covered by the Luxembourg National Health Insurance. So it's not a completely tiny application. Luxembourg is actually a bit bigger than what people realize. CNS has been using ODM to make Healthcare Act or Medical Act reimbursement decisions for quite a few years, and they have an extremely large rule base that's been deployed for a long time. they have problems. They've had problems. The problems are basically due to the fact that the rules that they have are the link between the rules and the changes to any changes to legislation and the policy documents, as well as the explanations of people who challenge the decisions that are made, are the links are not consistently maintained because they're based on leveraging BRMS metadata, which requires a human to constantly keep it updated, and it requires a human to put explanations in the rules themselves. And whatever goes beyond people's ability to keep up or people's ability to maintain the rules manually kind of falls by the wayside. So the kind of way this comes up is, questions that they ask, like, justify why a doctor or a hospital may ask, why was this reimbursement refused? Please explain it to me. Um, Somebody else may ask, please explain how you're implementing the rules on nursing procedures. Of course, it can also be things like, the rules just changed. I need to generate test cases. And not just, well, we'll get into that in a second, but it's not just test cases like generate the JSON files for me. It's at a higher level than that. And so on and so on. So we have been working with CNS now for quite a while on a few different things, but in particular on the specific problem of how do we create the linkages between the business rules that control the reimbursement and the policy documents that justify them in order to solve all of these problems. In order to do that, we've been developing a tool that we're using in this and as well as some other customer engagements that we call DecisionForge. And the idea for DecisionForge is to actually create, maintain, and use these linkages between policy documents and large decision estates. We're not solving the problem of, you enter a policy document and it spits out a decision model. They have decision models. They have a huge number of decision models. They have tens of thousands of rules. What we're trying to do is be able to ensure that that state is maintainable over time and is usable for some things that right now it's difficult to use it for. So what do? We use DecisionForge to discover information that's inside policy documents. We use it to create the trace, create the linkages between the rules and the policy documents. We use it to help explain why certain decisions were made by linking it not only back through the execution of the business rules themselves, which are fairly low level, but all the way back through to the policies that justify why those rules were made. We use it to help with governance. So how do you know which rules to modify when the policies change? How do you update your tests? How do you update the linkages and so on and so on? And then how do you test the system as this evolution occurs? And again, we're not talking about simply generating a bunch of JSONs that just look at edge cases that are mentioned specifically in the rules. We're talking about understanding the semantic context, the real meaning of the policy documents, and the real life use cases that generate useful tests, the happy path tests and the edge cases, but from a business standpoint, really understanding what the business case is. So let me show you what we've done in the case of CNS. And this is like another kind of, call it slideware demo of DecisionForge, which is continuing to evolve over time as we get more customer cases and do more with it. This is the DecisionForge desktop. There's a set of documents and a set of business rules artifacts on the left. There's this chat history on the left as well. In the middle, we convert the policy documents into a structured hierarchical set document that can be traversed and looked at hierarchically in the middle. And on the right, in this case, there's a chat for which you can ask all sorts of questions. In this case, The question was, what rule implements this regulation? And there's a kind of a drag and drop facility. So you look at the text for the policy, you say, oh, I don't know what rule implements this one. You just drag it over to the chat, and then it's able to give you an answer. So I won't try to read it or explain it to you. Maybe I will in a second, but it points to the specific rule that implements that policy based on the linkages that we create. And you can ask all sorts of questions here. And this is where you would ask a lot of the questions that I had mentioned earlier. Okay. Here's, like I said, the source policy documents are broken down hierarchically, and ultimately we end up in the specific articles and the specific text in these documents that typically corresponds to a rule. All right. Once we've kind of inserted the artifacts in Decision Forge, we can create links between the rules and the documents. And this is done by the LLM as well. And in this case, for example, I will try to spend, if I'm not taking too much time, I will try to explain this very quickly. There is a rule in Luxembourg where if you have a wound dressing and a blood sampling taken at the same time from the same site in the patient, you can't be reimbursed for both of those acts. A hospital can't be reimbursed for both of those things if they happen at the same time. Don't ask me to justify why they have this rule, but it's a rule. And so the Decision Forge was able to, based on the importing of the text and based on the importing of the rule artifacts, was able to establish this linkage, explain why it established the linkage, give a confidence, 86% doesn't mean much, but a high level of confidence that this is a good linkage, and then the human can accept it or not accept that this is a correct linkage. I just want to say one funny thing about this. The LLM was also able to determine that, in fact, the rule did not implement even though it's likely to be the rule for this particular text, it didn't implement it correctly. And you can try to read the BAL rule on the right and read the text, but I'll just tell you, the rule is incorrect. And it's incorrect for a very good reason, which is that the policy requires that you determine the exact site on the patient's arm where the medical acts were performed, but we don't have that information. Like, that data is never expressed anywhere, so the rule can't actually express the policy. But the LLM pointed it out, which is why the confidence is not 100%. And it also, it kind of creates the ability to have the conversation, well, why aren't we implementing the policy correctly? Is there a good reason for it? In this case, there was. Or is there not a good reason for it? In which case, we have to fix the rule. Or is the policy bad? In this case, it is, because the data is not available that lets us implement the rule correctly. So this is super valuable information. And the LLM does an extremely good job with recent models of making this determination. One of the reasons we think that's the case is because business rules are well verbalized in natural language, which makes it much easier for the LLM to draw a link between the rule and the actual text, especially when combined with other information like a business object model, an ontology, other information, structured input that the LLM can leverage in its so-called reasoning, if you want to call it that, to make this kind of determination. But the human always has to validate, because clearly it's a stochastic process and it could easily get it wrong as well. Okay, so this is just the text, the actual text that says what I said. Positions, blah, 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 cannot be combined if it's the same puncture point. The rule doesn't have puncture point, it just has session. So it's kind of wrong. It's the rule. Okay. Beyond that, we also do some level of entity extraction from the original documents. And here we're talking about not it's very much what Alan was saying before. Um, we don't go directly from a policy document, which is rather complicated and has a rather complicated set of use of terminology, directly to decision models. We have to go through some kind of pivot formats that provide a semi-structured level of information about the cases. And that's what we do here. So we're doing some kind of entity extraction, explaining what the different entities correspond to, and then pointing back to where in the document they come from. And that helps us move along to making the link directly with the rules. So I won't go into that more now, but it's another interesting part of this. Okay, case generation. As I said before, testing is important. Test generation is simply at the level of taking your business rules, understanding what the edge cases are, generating a set of JSON files or whatever that you can use for technical rule testing is cool and important. But at another level, what's also important is generating the actual situations that generate useful cases that correspond to the actual use of the system. And once again, by simply leveraging our understanding of the policy documents, the intermediate documents we've created, our understanding of the business rules, we can create much more focused sets of use cases that the BRMS can use to do the testing. Again, I won't go into that right here, but it's super cool. And ultimately, at the end, of course, we still generate the actual test cases that can be leveraged directly by the BRMS. Finally, explanations. And this is the thing that turned out to be get the CNS extremely excited. Some simple cases, the explanation simply provided by the rule that makes the determination is fine. And in those cases, great. But there's many other cases where the explanation requires understanding a chain of rules that fired. The rules can be quite technical. They use terminology which isn't necessarily very clear, and the way that they're linked back to the policy is not at all straightforward from the information merely contained in the rules themselves. So what we have done is create a much more, let's say, business-friendly or case officer-friendly explanation of certain cases that uses all the linkages, all the information that we've been able to garner from the policy documents and from the rule base, so that once we have a trace of how the rules were executed, we're able to construct a narrative that makes a lot more sense. At CNS, they have a few hundred different case officers who have to respond to questions from citizens when they have questions about reimbursement, or even more importantly, hospitals and doctors, practitioners. And they often need to provide these complex explanations. And right now, the way they work is they go back to the rule authors when they have a complex case, and the rule authoring team actually has to spend time understanding their rule base and give them a business explanation of why the rule got fired, which is suboptimal and kind of a waste of time on the rule authors side. So this is cool. Okay. So get to a conclusion here. We have these 4 different real cases. We have one in deployment, 2 that are I would say, in deployment development. In the case of CNS, they have a strong desire to do this, put this system in production, because the POC was extremely convincing. Another interesting lesson from the public sector, the public sector has a lot of weird constraints. One of which is you have to go through a public tender if you want to propose any kind of serious development, and the public tender takes a long time and requires competition and so on. And the other one is that in the case of Luxembourg, this business about not trusting AI is taken to a high level, and they are in the place of putting in a Luxembourg public sector AI service that all the public sector AI applications have to leverage if they want to use AI. And so we're kind of waiting for them to finalize that before we can go to deployment. In the meantime, we're doing a lot of other work with them on other rule-based topics. All right. So that's what I wanted to talk to you about. Everything I talked to you about regarding the public sector, I think from a technical standpoint, is nothing really specific to a public sector. In the case of service offerings, I think any organization offering a service to its users or an internal service faces similar problems of trying to map situations to cases. And I think there are a lot of organizations that have huge rule estates where managing the rules, explaining them, trying to understand how to map policy changes into the rule base, how to manage testing, and so on, is an extremely large problem. And we're talking to others about leveraging Decision Forge and our own skills on how to solve that problem as well. So clearly, we'd be happy to talk with everyone here, either on partnership or working together.
Okay, thank you very much, Harley. That's exactly what I expected. It would be real world applications. And for such a young company, this is a great achievement. We saw 4 different real world cases. And no wonder, because Harley and his colleagues are extremely experienced people in this area, and now the way how they use AI together with rules are great. We have time only for one question. Anybody? Harley can answer everything on in the chat later.
Yep. And I'm more than available on LinkedIn, email, etc. for conversations.
Harley, you can type in chat your email so people will contact you.
Okay. Yes,
Okay.
I'll put it.
Okay. Thank you very much, Harley.
Thank
And
you.
we need to continue. Let me stop this.